Okay, example 4. We're asked to solve a logarithmic equation, and we almost have this form, but not quite. So I can't use x equals y because I have this 1/2 here. In order to combine these two, they have to have the same base. In order for us to use the product property to combine these two logs into 1, I have to somehow make 1/2 into log base 16. So my goal is log base 16, that I'm going to turn 1/2 into that. Well, let's think about this. If I think about my definition of logarithms, I have log base b of x equals y. And what I want is log base 16 of some number, but I don't know what number, is going to equal 1/2. Because then, if I have this, instead of writing 1/2 here, I'll just write this. Thinking of my definition of logarithms and how I can use that to solve an equation like this, an equation with a log on one side. So now I've got a separate equation that I need to solve in order to solve this one, just to substitute there. Well, recall that log base b of x equals y if b to the y equals x. So I'm going to solve this by converting it into its exponential form, which is going to give me 16 to the 1/2 power equals x. This is the same as the square root of 16, which is 4. Therefore, log base 16 of 4 equals 1/2. These are equivalent. Since these are equivalent, I can write that up there. I can substitute. Now, my next step is to combine these two logs on the right using the product property. Log base 16 of 12x minus 21 equals the log base 16 of 4 times x squared minus 3. Now I have it in this form, and I can say, okay, 12x minus 21 equals 4 times x squared minus 3. And then I just solve, as usual. This is going to give me 12x minus 21 equals 4x squared minus 12. I have a quadratic equation. I need to first simplify, so let's subtract 12x from both sides. I'm going to set the whole equation equal to 0. That's negative 21 equals 4x squared minus 12x minus 12. I'm going to add 21 to both sides to get 0 equals 4x squared minus 12x plus 9. I'm going to rewrite this in a more standard form with the variables on the left. Now this is just a matter of solving the quadratic equation. And this is actually a perfect square. It's 2x minus 3 times 2x minus 3 equals 0. And you could check this out to see that this 2x times 2x is 4x squared. 2x times negative 3, that's negative 6, plus negative 6x plus negative 6x is negative 12x. Negative 3 times negative 3 is 9. According to the product property, if 2x minus 3 equals 0, and these are the same, so I only have to look at one factor, then I will have a solution. So 2x equals 3. If I solve for x equals 3/2. So x equals 3/2. Now my last step, this is a potential solution, is I need to go ahead and check it right here. Let's let x equal 3/2, and we're going to insert that into log of 16, 12x minus 21. So x equals log base 16, 12 times 3/2 minus 21. Not x equals. So log base 16, this cancels. This becomes 1, and this is 6. This is 6 times 3 minus 21. So this is log base 16 of 18 minus 21, and that gives me log base 16 of negative 18. Therefore, this solution is not valid. Not a valid solution. And since that's the only solution I have, there is no solution to this equation. So, no solution. The only solution I came up with was an extraneous solution. So I solved this by first converting it to this form, and I did that by setting up an equation where I figured out what x had to be for me to write 1/2 in the form log base 16. And I used the technique of converting this to the exponential form, 16 to the 1/2 equals x, and solving for x. That told me that log base 16 of 4 equals 1/2. So instead of writing 1/2 here, I wrote log base 16 of 4. Then I used the product property to combine the two logarithmic expressions on the right. Then I used this property and I set 12x minus 21 equal to this expression, solved using factoring a quadratic equation, but then I went and checked my solution and found that it was not a valid solution. Thanks for visiting Educator.com. That concludes today's lesson.